Anytime we're looking at a compound, the very first question that we need to ask ourselves is, does it contain a metal and a nonmetal? If it does contain a metal and a nonmetal, then it's going to be an ionic compound. If we're looking at an ionic compound that is made of just two elements, for example, if I am looking at something like NaCl, or if I'm looking at MgCl, CaCl, all of these are binary, meaning they're made of just two elements, one metal and one nonmetal. The naming is very simple. All I'm going to do is name the first metal and then change the name of the second element, the nonmetal, to end in IDE. So if you follow your flow chart, we would name this one sodium chloride. We would name the second one magnesium chloride. And we would name the third one calcium chloride. Now the charges on these do need to be balanced. The charge on sodium is a +1. The charge on chlorine is a -1. They balance each other out to have no charge. Now, the charge on magnesium is a +2, which means that this compound of magnesium chloride right here is going to need 2 chlorines because I'll need 2 negatives to balance with the 2 positives in the magnesium. Calcium is also a +2 charge, so the same thing is going to happen. I need to name them by naming the first element and then changing the second element's name to IDE and making sure that the charge is balanced. These are called binary ionic compounds, and they are made of one metal and one nonmetal that have charges on them. With ionic compounds, sometimes my metal is a transition metal, and a transition metal is located right in this center portion of the periodic table. So for example, if I'm making a compound that has copper, and I am going to be making a compound with chlorine with that copper, I need to look at the overall compound to figure out what's my charge on the copper. Copper can have a +2 charge or a +1 charge. Well, chlorine, I know, has a -1 charge. So looking at that, if I have a compound that is CuCl, I know then that my copper must have a +1 charge because I only have one of them. Therefore, we would call this compound copper 1, the Roman numeral 1 in parentheses, and I do the same thing with the second part of the name. I change to IDE, chloride. Now, if you saw copper with 2 chlorines, that must mean that I have a total of a -2 charge. And so now I cannot have copper 1. I only have one copper atom here, which means to balance the -2, the charge on that copper must be a +2. So I must have copper 2 chloride instead of copper 1. You have to figure out the charge of the transition metal by looking at how many of the negative ions you have. The next type of compound are compounds that contain polyatomic ions. The word poly means many, atomic atoms, so many atoms that make a single ion. So for example here, we see KOH. The OH is a polyatomic ion. The OH is many atoms that have a charge on its own. OH is hydroxide. This is an OH with a negative charge. Hydroxide has a negative charge to it. NO3 is a polyatomic ion. NO3 has a charge to it of -1. It is many atoms together forming an ion. Again, we see NO3 here. So let's name these polyatomic compounds. We still name the first element. K is potassium. So in my KOH, I am going to name potassium. Then I name my polyatomic ion. I look on my paper and I find OH. OH is called hydroxide. So this is potassium hydroxide. The next one, I do the same thing. I look at Na. Na is sodium. I name my first element. I look on my polyatomic ion sheet and I see that NO3 is nitrate, and I name it nitrate. Now, on the last one, iron is a transition metal, so I need to figure out what kind of charge does iron have. NO3 has a negative charge to it, but my subscript says that I have 3 NO3s. So attached to the iron, I have 1 NO3, 2 NO3s, 3 NO3s. So that means right here I have a total of a -3 charge. I only have 1 iron to balance that -3 charge. That means that this iron here must have a +3 charge. Therefore, I have iron 3, so I put my 3 in Roman numerals in parentheses, and then I name my polyatomic ion, which is nitrate. And I'm done. If I'm going the other way, if I'm given the name potassium hydroxide or sodium nitrate, you're going to have to recognize that this is a polyatomic ion. Looking for any name that does not end in IDE is going to be your clue that is a polyatomic ion. So we just went over these 2 types of compounds, a simple metal with a nonmetal, such as NaCl, or a transition metal with a nonmetal, such as CuCl or CuCl2. The first one is sodium chloride. We name the first element and we change the ending on the second element to IDE. When we have a transition metal, we're going to have to indicate what kind of charge the copper has. Chlorine has a -1 charge on it, and so if I only have 1 copper, my first one must be copper 1 chloride. If I have 2 chlorines with the copper, such as in with the second one, I must have copper 2 chloride to balance off the 2 negatives from the chlorine. The next type of compound that we went over is a metal with a polyatomic ion. Poly meaning many, atoms creating an ion. So, for example, hydroxide. OH has a -1 charge to it. It is called hydroxide and is a polyatomic ion. NO3, more than 1 atom, has a negative charge to it, and it is called nitrate. You can use your flowchart to help you with naming these compounds. So here is our flowchart. You can see that no matter what kind of polyatomic ion we are making, we always name the metal first. So if we have sodium chloride, we name sodium first. If we have copper chloride, we name copper first. Now, sodium is not a transition metal, so I can ignore step 2. I simply name the nonmetal and change the ending to IDE. So Cl is not chlorine, it's chloride. In the case of copper, copper is a transition metal, so I need to figure out what the charge is. Chlorine has a -1 charge to it, so my 1 copper atom must have a +1 charge to it, and I still do step 3 where I name the nonmetal and I change the name to IDE. So I have copper 1 chloride. The other type of ionic compound we looked at was ones that have polyatomic ions with them. So I could have sodium with hydroxide, hydroxide being the polyatomic ion. Sodium has a +1 charge, hydroxide has a negative charge. I still name the first element, sodium, and then I give the name of the polyatomic ion, which is hydroxide, right here. Now, if it's a transition metal, I have to do the same thing as I did with the copper chloride. So let's say that I have copper with the hydroxide. If I had 2 hydroxides, then I have 2 hydroxides with a -1 charge. So this entire thing right here has a total of a -2 charge. That must mean that my 1 copper has a +2 charge. So I would name this copper 2 hydroxide. Now, if I saw that my compound with hydroxide and copper was Cu with just a single OH, and I don't need parentheses around there because I just have one of them, then that would indicate to me that I have a total of a -1 charge here, which means that my copper must have only a +1 charge because I only have one of them. So my name of this compound would be copper 1 hydroxide. So you want to recognize that difference.